Welcome to my presentation. Stefan said it will be a deep dive. I only have 20 minutes, so I cannot deep dive into anything, but I will tell you a little bit about harmonizing OPC UA information models. From my background, my name is Wolfgang Mahnke. I work for the company ascolab as a consultant. We are very strong related to unified automation, so I also have a unified automation email address, and unified automation then does SDK software development kits and other tools like the UA expert and a generic OPC UA client, gateways, the modeler, and so on. From my background, I'm involved in OPC UA since now 17 years, and I'm chair of the harmonization working group, so that's probably the reason why I was chosen for this presentation here. And I'm editor of a bunch of specifications, and I will emphasize on two of them today in the presentation. One is the asset management basics, and the other one, the machinery specification, Stefan already mentioned in his presentation. So before we go into harmonizing information models, let's first talk a little bit about having standardized information models at all. So you hopefully are all aware that with OPC UA, you have a common communication infrastructure in place, so you can communicate. You have access to the metadata, to the semantic can be provided with the server, and an OPC UA client, as you can see here on the left hand, can access various OPC UA servers, get all the information out of there. But as you also can see, so I have here two robots with an OPC UA server on top, one from vendor A, one from vendor B. And if they both provide an information model, the information models will just look differently because people do modeling things just in a different way. And the idea to have standardized information models is that you standardize how to represent a robot, for example, in OPC UA, and then you have a common structure on how to access the information and thus interoperability on the model layer. So this is a very important thing, and it's built in OPC UA that you can do this, and it has been used very much from the beginning, but it has become much more used today. And sorry, we already have over 40 companion specifications released in different areas and different domains, defining things. And this is because it is so successful, we're talking now about harmonizing those information models. So if you look at this OPC UA's information modeling capabilities, you can do a lot of things. You have objects, variables, methods, events, and so on. Various ways to do things, but that also means that a problem can be solved differently. For example, if you want to provide quality data of a machine, you can do this by accessing this via a method, providing variables where you can read or subscribe to or provide events. And although the quality data of different machines might be completely different, the mechanism how to use it would be nice to always use the same. So in a nutshell, doing similar things in a similar way, but there are also other things where you want to do the same thing in the same way. For example, you can see here in this figure, we have now not 3 robots, but a robot and a machine tool, injection molding machine. And they are, of course, different. They provide different data, but there are a couple of things where you want to do this thing in the same way, like the identification, the nameplate of the machine, what components are used in the machine, the status of the machine, the operation mode. Things like this are common across different types of machine, and it's desirable to have them in a common model. So the general approach is harmonizing information models. We have one thing, it's a white paper on best practice information modeling that's describing that you hopefully do the same thing, similar thing in a similar way, but then we have more generic information models which can then be refined and used in more domain-specific companion specifications. As you can see here in the example, we still have the robot, machine tool, and the injection molding machine. They all have their own standardized information model, but they can use then as a commonality, a common specification like the OPC UA for machinery. And you can see here a few examples of more generic ones coming from the base specification, like the state machines file transfer, base network model, or coming very soon, common reference types. We have since a long time the devices. We also have the asset management basics. As you can also see from the arrows here, a bunch of those have been created based on work in the harmonization working group. Some were moved to the base specification working group. Some are still maintained in the harmonization working group. And then, of course, we have the OPC UA for machinery specification, which is created in cooperation with the VDMA. So kind of the own harmonization effort in the VDMA in the area of machinery. And sorry, and I want to, before I go into what the specific companion specification, let's just give you an idea. So here are the companion specifications that are currently released. Those are the green ones. We have a few as release candidate and several in development. And I don't want to jump into all the details of them, but pick up two of them. And this is the devices specification and the machinery specification. And as you can see, the devices specification is used in many other companion specifications. So it includes the identification of the device. And as you can see, this is spread all over the place for other companion specification. And in the area of machinery, the machinery specification kind of takes the same role. And as you can see from the arrows, also the machinery is actually using the devices specification. So Stefan said in the morning, yeah, if you want to look at something, you have to implement the machinery specification. I do agree on this is a very important one, but actually it's still using the devices specification. So the first thing you're using is actually, sorry, the devices specification. And let's take now a look at those two specific specifications very shortly, because I don't have much time. The one is the machinery specification. The first release, version 1.0, was in 2020. General idea is we don't define a base type like, oh, base machine type or something like this, and you have to derive from that, but we do define building blocks for different purposes, and you can apply those building blocks. It's not an all or nothing. You can say, okay, this is something I want to do, but I don't want to expose, for example, the components of the machine. So for my use cases, I don't need this, then you don't need to use this one, but maybe some other things you're using. And then the idea is, of course, you can use the specification by itself in your machine, but typically it will be applied by various more domain-specific companion specifications, also in existing companion specifications. And the first version we had is, or we still have, is having very small use cases. In a nutshell, it's just but very basic is, if I'm connecting to a server, I want to see all the machines of the server. I want the access path to go to all the machines. And of course, if your OPC UA server runs on the machine, it will very likely just contain one machine, but you might have all kind of flavors on aggregating servers where your OPC UA server provides you more than one machine. But even if it's only one machine, you need to know where do I get this? You don't want to browse the whole address space, but have an easy path to get there. So this is addressed in the first version. And then, of course, the identification of the machine, that's very, very important. This is, as I just mentioned, already based on the devices specification. So the devices specification already defines identification. We're extending this, so we're adding a little bit information like the build date of the machine, but we're also refining this, how to be used in the machinery domain, what exactly to put in what property, and have this globally unique identification and things like this. So this is all addressed in the machinery specification, so that in a nutshell, you do not really need to look in the devices spec, although we're using the stuff there because it's more refined in the machinery specification. Of course, you still have the dependency to the devices, and that's intended. This next version, also already released, is the 1.01 version. And this was addressing also components of a machine. And this includes then, I want to be able to relate the machine to its components. So if I'm on the machine, I want to get the components of the machine. And of course, I also want the identification of those components, of course, also based on the device's specification and specialized for the machinery domain. We did this machine identification and component identification a little bit different, because we're saying, okay, for a machine, the machine vendor really can provide the globally unique identification. If it uses components from some other vendors, this might not be possible to do. So therefore, this thing is not mandatory for the components, but it's mandatory for the machines. Currently, we have out a release candidate since, I don't know, 1 or 2 or 3 weeks or something like this. And this is addressing as use case machine monitoring, but it's focusing also on very high level. So we have a state of a machine at an operation mode. You can see here the state is something like, oh, I'm executing, I'm not executing. So this is knowledge the machine has by itself, so to say. The machine doesn't know if it's executing or it's not. And then the operation mode is more something that typically comes from outside, that you're saying, oh, I'm now in the setup phase and I do a dry run. Then the machinery item state is more coming from the machine itself, whether the operation mode comes typically from a local HMI or wherever. And this is kind of the top level information. It's intentionally not the machine state, but machinery item state, because we're saying this can also be deployed to the components of a machine. And the purpose is, of course, you get an overall status of the machine and its components, and can be used as base for KPI calculations. And we're using here as a modeling concept a state machine. The idea to have a state machine is that, and not just an enum or something like this. So we're a very open state machine, allow transitions between everything. But if you want to extend this, for example, oh, my execution is starts with a preparation phase, then maybe I have a manual execution, an automatic execution or something like this. If you want to do the substates either vendor specific or in a specific domain specific companion specification, you can just extend those things. So this is what's in the release candidate. As an outlook, we're already almost done with which will not be a new version, but a new part of the specification on result transfer. So if you have potentially larger results to transfer would just not fit into a variable, and you need to do some calculations around that, this is addressed by the result transfer. We're currently working on job management, and of course, we will continue addressing common functionality in the area of machinery. And you have seen it's already used in several other specifications. It's not used in all companion specifications in the area of the machinery at the moment, because some of them have been released before that, and so they will adapt this over the time of the next release. Coming to the asset management basic specification. So in general, if you look into companion specifications, many of them, if you look into what's their scope and so on, they somehow address asset management. And the idea of this asset management basics is to define a base that can then be applied and extended in various companion specifications, so that not everybody is doing asset management differently. And if you're a client, want to access asset management related data, you need to understand management data, but you have a common infrastructure which you can use. So the approach is very much like the machinery. We have building blocks, only the needed functionality can be selected from the specification. The idea is to support various also existing companion specification. And also here we're based on existing specifications, so we're not trying to reinvent the wheel. And so we're using, for example, the devices specification, but also other specifications as well. So it's very similar to what we're doing with the machinery, but there's also some differences. In the machinery, we're really specializing things, and for the area of machinery, specifying exactly this one solution for a problem. With the asset management basics, we're keeping it a little bit more open. So saying, okay, you can, for identification, you can use this variation or that variation. And that makes it easier to be applied in also existing companion specifications. The drawback is that for a client, of course, a client now needs to check, this variation and that variation, so that he gets the identification, for example, of all the assets. And the use cases addressed in the first version is, of course, the identification of an asset based on the devices specification again. So we're not doing anything here with the information model. We're just defining new conformance units for that. The identification of the machinery specification is, of course, compatible to what we're doing in the asset management. So if you implement the machinery specification, the identification of an asset is automatically working. We have a mechanism to discover assets. There we're using part 17 of the base specification, alias names, and we define specific alias name categories so that you can come to the assets. We provide the health status also based on the devices specification, providing you a high-level assets status based on the NAMUR recommendations. We have specific information on what actually went wrong. You can provide also the root causes for things going wrong. We have standardized categories. We provide information about technical specification about the asset, from the version number to operation counters. We're not defining operation counters, but the infrastructure to provide operation counters. What operation counters you have, of course, depends very much on the assets you're doing. We provide what OPC UA functionality is supported in general. That's, by the way, also already defined in the base specification. We're just referencing this. Links to digital records. We have a classification for assets based on the dictionary references, part 19 of the specification, that allows various classifications of assets like E-class and so on. And we do define maintenance events, upcoming events. Oh, the machine needs to be maintained in 2 weeks, but also events from the past. And also there we have standardized categories. This specification is out now as a release candidate, will soon be published. The reason why we did this now already is that the field exchange, so we'll hear about this after the next break, I think, will already use this specification. Otherwise, it's a release candidate. So of course, no release specification is using this at the moment. We have a few more use cases we're still working on. Originally, we wanted to solve all of them before we release version 1.0. Now we will have a version 1.01 very soon coming afterwards. For the technical specification, also provide skills, capabilities, and requirements like, oh, this machine needs a power supply of whatever. We're talking about localization. There are different localizations: hierarchical localization, time zones, digital localization, operational localization, and finally, the structure of an asset. We will work on things in the future, like the relative location, geospatial location. There's, for the first case, there is already a working group working on that, and we're saying we just will reuse what they are doing, and the geospatial location. There will hopefully soon a working group working with that, and then we will use those results as well. So to conclude this short presentation, companion specification provide interoperability on the model layer. We have a lot of companion specifications out there. And the reason to harmonize them is that you have similar things in a similar way, in the same way, same things in the same way. We have the best practice to do the similar things, and those generic specifications to solve things in the same way. And the machinery specification and the asset management specifications are two examples of those generic specifications. And that's it from my side. Are there questions, or do we have time for questions?
Okay, thank you, Wolfgang.